వెల్కమ్ బ్యాక్ టు కెమిస్ట్రీ క్లాస్. యాసిడ్స్ అండ్ బేసిస్ టాపిక్ గురించి మరికొన్ని అంశాలను శంకర్ గారి ద్వారా తెలుసుకుందాం.
Till now we have been discussing about the Bronsted-Lowry theory of acids and bases. Now we will go to the next theory, which is called Lewis acid-base theory. And Lewis acid-base theory is more a simplified theory when compared to the previous one, the Bronsted-Lowry theory of acid. And one more name given to Lewis theory is also known as electron pair theory, because basically it deals with we are defining acids and bases with respect to electron pairs, so it is also called electron pair theory. In the previous theory we are discussing acids and bases in terms of proton, so therefore it is also known as a proton theory of acids and bases. So the next theory we are seeing Lewis theory. Lewis theory of acids and bases, which is also known as electron theory or electron pair theory. So why it is called electron pair theory means basing upon electron pairs we are defining both acid as well as base in this theory. So it is also known as electron pair theory. The previous one was called proton theory because there, depending upon proton, we are defining acid and then base. Now let us see here what is the meaning of acid and what is the meaning of base in this theory. If you take a simple example like ammonia, that is NH3 plus HCl giving rise to. Now here if you see the reaction here, ammonia has a lone pair of electrons on nitrogen, whereas HCl is having proton H plus and Cl minus. Proton is an electron deficient one. So if you observe the reaction completely here, wherein it forms ammonium chloride, that is NH4 plus Cl minus. Actually what is happening is an electron pair which is present on nitrogen of ammonia is being transferred to the proton of H plus. So electron pair transfer is taking place from ammonia to H plus of HCl. So now HCl acid, also known as here, it is electron pair acceptor. This is electron pair acceptor. And whereas the ammonia which is giving electron pair known as electron pair donor. Now in this theory, electron pair acceptor is defined as an acid and electron pair donor is defined as a base. So electron pair donor is called base in Lewis theory. Electron pair acceptor is called acid in the Lewis theory for us now. And here whenever electron pair is being transferred, say from ammonia to HCl, actually a coordinate covalent bond will be forming between the nitrogen of ammonia and the proton of HCl. That is to say, we can represent in this way also NH3 having electron pair here plus HCl proton, this is giving to this one, and if you see the final equation it will be like this, that is nitrogen, 3 hydrogens here, this pair is being transferred to H plus here and thereby this exists as ammonium ion and then Cl minus here. That implies a coordinate covalent bond is being formed between the nitrogen of ammonia and then H plus of HCl for us now. There is a dative bond is being formed. So this bond is coordinate covalent bond, or you can call it as a dative bond. So in this theory, electron pair acceptor is acid and electron pair donor is base. Electron pair transfer, that is say from one substance to another substance, and then the coordinate covalent bond formation, that can be defined as neutralization in this theory. So in one word to say, acid is electron pair acceptor and base is electron pair donor, and neutralization reaction is electron pair transfer and then dative bond formation must happen. Then only we can define the neutralization reaction according to Lewis theory. So now in this theory we have seen meaning of acid, meaning of base, as well as what is the meaning of neutralization. Now various examples of Lewis acids and various examples of Lewis bases must be discussed, because in the examinations normally what they are asking is write a short notes on Lewis acid base theory. So while writing the short notes, we need to define the meaning of an acid first, a simple example we can give, and the meaning of a base as well as simple example we can give. But there are various sets of examples are being given for us. So therefore those examples are also very much important in the examination point of view. Therefore we take up those examples in an order for us now. Now the examples of Lewis acids we need to take up first. Then we will discuss the examples of the Lewis bases. So now Lewis acids. So Lewis acids are also known as, one more name is there for them, that is called electrophile. Now what is the meaning of this word electrophile? It is actually two parts we can say, electro and then phile, or electron and then phile we can say. Electro word stands for the electron only and phile stands for liking. So any species which is liking the electrons, that is called electrophile for us now. So it is liking electrons means we can say that it doesn't have any electrons for us now. Means electron deficient will always like electrons. So it is called electrophile. Now various sets or various classes of examples are there under the electrophiles for us now. The first set of examples, there are some neutral molecules wherein we have less number of electrons around central atom. Less number of electrons means I mean to say that less than the octet. For example, BF3 is there, boron trifluoride, AlCl3, aluminum chloride, BCl3 also, boron trichloride. We all of know that the boron is having only 3 electrons around or 3 valence electrons are there around boron. And in boron trifluoride, 3 bonds are being formed by the boron, and implies each bond will be considered to be a pair of electrons. Therefore, here we have BF here, one bond here, another bond is there, and one more bond here now. So altogether, there are 3 bonds around boron, and each bond constitutes 2 electrons. That is, 1 electron is coming from the boron here, and 1 more electron comes from the fluorine. Like that, 1 from boron and 1 from fluorine, 1 from boron, 1 from fluorine we have. Altogether, if we are seeing around the boron, in boron trifluoride here, we have only 6 electrons are present, that is 2 plus 2 plus 2. Altogether 6 electrons are there around boron. Whereas to get the octet configuration, which we consider to be very stable configuration, this requires another pair of electrons. Therefore, whenever BF3 involves in reaction, it tries to take electron pair, that is electron pair acceptor, which is also called electrophile or the Lewis acid. So we can say that all electron deficient molecules which have less than octet around the central atom will be always acting as Lewis acids. Because they have less electrons, they are trying to take up another pair of electrons to get the stable octet configuration. So this will be one set of acids for us. Now when you take the second set of the acids here, so all cations which have vacant orbitals in the valence shell. For example, H plus ion is there, a cation here. It doesn't have any electrons in that. It is ready to accept electron pair for us. So cation having a vacant orbital we can take. Then another example you can write, D block metal ions we can write, Fe plus 2 we can take, or even Fe plus 3 also we can write. And then even Cu plus 2 also, or else Ag plus, and so on and so forth. All these cations, they are having vacant d orbitals. Vacant d orbital in the sense they can accept another pair of electrons. For example, when you see a reaction of silver ion here, and all of us are familiar regarding one reaction, that is silver chloride is soluble in ammonia. It is forming a soluble complex. So actually what is happening in this particular reaction here now? Silver chloride plus ammonia means here actually silver ion is there in the reaction. So silver ion plus ammonia. Ammonia is having a lone pair of electrons here now. And silver ion is accepting electron pairs from ammonia here. That is, it reacts with 2 ammonia molecules here. And finally it forms a silver diamine complex is being formed here, taken plus C. So here, because of the formation of silver diamine complex, the silver